gas accounting. So S is this big capital bold S. That's the set of all services which are going to be accumulated in the block. This is different to the set of work reports because work reports may include the same service multiple times. Right? So now we're just going to boil this down to just the set of services. Oftentimes, I mean, in the very first sort of instances of JAM, we're probably just going to see one service, the parachain service. And then S will always just have one item in. But as more services get added, S may have multiple items in as more cores are used for those additional services. Blah, 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 blah. Okay, so S, very simple definition here. For all work reports in W, for all work results in the work report, it's the service associated with that work result. And in addition to that, we're always going to include these 3 services, right? These are special services, privileged services. Chai, I think it's Chai, M, A, and V, right? And I think I already covered the meaning of these, but basically there are service that can set validators, service that can set what we do on the cores, and service that can decide who these other services are, including itself. Yeah, those are our 3 privileged services. They always get executed. Realistically, when JAM starts, there'll probably just be one. I mean, they'll all be the same service. They'll all be the parachain service. And then this just means the parachain service will definitely always get executed. All right. Now we calculate the gas attributable to each service as the sum of the service's work output share of the report's elective accumulation gas, together with the subtotal of the minimum gas requirements. So there's a little bit of fiddliness going on here. A service can specify a minimum gas requirement for accumulation, right? It's like, when I get accumulated, you have to give me at least this amount of gas. Because, there may be some important work to be done in accumulation that just needs this gas. Parachains are a simple example. They have to move the block header hash along. They have to, actually, I think that's about all they need to do. There might be some message passing as well, right? So there is some non-negotiable about amount of gas that we want to be able to sort of attribute to a particular service getting accumulated. A core has a particular maximum amount of gas. So once we remove this minimum amount of gas from the maximum amount of gas, we've got our elective gas, right? The gas that isn't currently sort of assigned, right? It's like this has to be sort of spread out between the services. So services get the minimum amount of gas, that's guaranteed, but they can also get some extra gas. And the idea is that services can split their workload up into the work that they really have to do when they get accumulated, and then the work that they should do at some point, but they don't necessarily have to do it sort of immediately on accumulation. Kind of like cleanup work, yeah? So we leave it to the work package author to figure out what kind of ratio each service, how we split up this excess gas between the services, like what ratio they get this excess gas in. The elective gas. This like slightly big scary function here is what that's doing. So it's mapping service index to gas. Again, this said gas sometimes is negative because, like, for example, if a PVM is executing, it might over-execute and then go into the negative, right? But most of the time, especially here, it's going to be positive. So that should really be N. All right. So the service S maps to the gas. Right, well, it's going to be sum, right? So we're going to sum up over the work items that we're going to be accumulating. Then we're going to look in at every work report and check for what we want to know about the work reports that are this service S. And then we're going to go into the service specification and look at the gas that it needs for accumulation. That's G. On top of that, that's G, right? I think there might be a mistake in either here or in the previous one, because I think in the previous one this was M. and I'm not sure, it should be either M or G. But anyway, G, or I think it's G. I think the other one was wrong. That should have been G instead of M. Anyway, so we're going to go into the service, look at its minimum gas for accumulation. It gets that anyway. So that's why we're going to sum all these up to begin with. In addition to that, we're going to add our ratio. So the ratio is this G, which is the work report gas ratio. If you remember, I sort of mentioned the existence of this, but didn't go into detail previously when I was talking about explaining the fields of the work report. We're going to multiply this by basically all of the excess gas on the core, which means summing up all of the, first taking the gas on a core, removing this term, right, which is basically what this does. So go through all of the work reports, look at the minimum gas, and take away that service's minimum gas. So find the elective gas, so the gas that can be assigned, that isn't already accounted for by the minimum, and then divide it by the sum of all of these ratios, of all of this R component, and then multiply it by this specific R component, and then take the floor so we don't accidentally go over our maximum gas. Good. You might need to look at that in a bit more depth, but I would hope you sort of get the idea of what it's trying to do and how it's doing it.